Hello. We are very pleased to be here sharing the experiences and learnings from our work in HP Personal Systems software. This presentation, actually, it could be the third episode of a previous presentations held here in past editions of Spark Summit. The first one we did 2 years ago was related to how do we capture data from millions of devices, specifically PCs in the field, and ingesting their telemetry data at speed in our ORC data lake. Last year, I presented here how did we implement our data unified pipeline, how did we transform this data coming from the telemetry using Databricks Spark, how did we transform it at scale, and then we normalize, we filter, we clean it, we transform, we enrich this data, transforming this raw data to silver data. And based on this silver data, how did we created machine learning services on top of them, more specifically long-term device health prediction using deep learning, long short-term memory models. And then, fortunately, we succeeded. So we did a good job doing these jobs. We created a lot of different services, and rapidly we understood, all right, we created the services, but what's the good way to deliver the service to the field, right? To the business users, to the users in general. And this is what this talk is about. So different than the other ones where we focus on the construction of machine learning models and services, we are talking about the user experience and how do we leverage the data coming from these models. But let us introduce first.
Yeah, so we are both from Brazil. My name is Rafael Zotto. I'm a solutions architect for the data science team. And basically, my work nowadays is focused on building conversational interfaces, specifically using applied AI and focused on natural language processing.
And I am Franco Viei. As most of you, I started as software engineer, then cloud engineer. In the past 6 years, I'm working as machine learning engineer and data science developing predictive models and deep learning models at HP Personal Systems. Again, I told that this is part of our work in HP Personal Systems software. I'm not sure if you know that HP has a software unit on it. So when we're talking about data and deep learning, data is very important. So this is where this data coming from. I'm talking about every device we deliver to the field. We consider them as IoT devices. They are instrumented, and we are collecting data from them. And if you agree, of course, your devices are sending data to HP. And based on this data, we are learning not only how these devices are being used, but also what kind of experiences you are doing, what kind of activities you are doing with them. This is pretty much the presentation I did last year, describing the pipeline. So we have here at the left about 40 to 50 million devices in the field sending data every day to us. And then we have this data collected, transformed. So most of them, they send data as JSON files. We transform this data using AWS Kinesis there. Then we use Databricks Spark to process this data and transform, generating Parquet data lakes, enriching this data, and making them ready to data analysis and prediction models. So this is very important because this is the basis of the virtual assistant. Every data coming from the device from the field, they passes this workflow. So we execute this as many times as needed to generate filter data and good quality data to process and infer NLP queries. But the problem there is we do all of this, and then there in the end, we invest a lot of money doing this thing, we invest a lot of time, we generated very good insights, and we store these insights in database tables, hide them from the others. And then in our team, we start talking about, so we have good data, we have device health data, we have data from manufacturers, we have data from the profile, the usage of this device, we have data about many perspectives. But few of this data is being utilized because if you look these tables, what we use there is kind of reports or applications performing as reporters, right? So every time I need to go to this data and generate a new view of this data, I need to go to the development cycle and kind of a new feature that have to be implemented to deliver this data. And then we thought, okay, is there a different way to do that? And this is what my colleague Zotto is talking about.
Yeah, so exactly, that captures quite well the situation that we are facing. We have lots of devices sending out telemetry to our pipeline that does all that processing that Franco described. And at the end of the day, we have valuable information that can either be consumed in forms of insights or predictions. But the problem that we have is that we are using that information to feed reports. And to be honest, we have just quite a few of them. And to add on that, most of those reports are not even configurable, meaning that if the user generates a report and needs to know more details about the information that is presented there, he cannot find it, although we do have the information. So we started to think, well, how could we deliver that information in an easy way? How could we democratize the information to our insights and recommendations? And before getting into details of that, let me zoom out a little bit and share some context. I will be talking a lot about users during this talk. And when I say users, I invite you to think about an enterprise environment. So we have at least two major actors playing there. We have the fleet manager and the end user. The fleet manager is the one that is actually concerned about making sure that all devices are working as expected. He wants to understand the status and maybe try to anticipate potential failures. On the other hand, we have the end user that is basically all that he wants is to sit in front of his computer and do his work or go to the printer and get his printed job. So we started to think how we could deliver our insights and prediction to those actors. We wanted to create something that is always available, and more importantly, we wanted to create something that is dynamic. Just like we do have reports, but we want to create something that is more flexible, that if the user wants some more details, he can go ahead and get those information. And we started to think how we as human beings, we get this information. And we find out that, well, that's quite obvious. We do this through our natural language. We do this by asking questions and getting responses. And if the response is not exactly what we want, we ask for follow-up questions. And that's exactly our first take. So we started to do some investigation on the state of the art, on solutions around that. So all we wanted to do was given a sentence or a question that is asked, break down that in pieces of information that we could produce a SQL statement and run that against our databases. So we did some prototypes using some of the solutions that we have out there, but it didn't took us much time to find out that maybe that was not the right way for us to go, because we learned from this prototype that we built that most of the times the user is not doesn't know exactly what he's willing to ask. So we learned that more important than the question that is being asked is the intention behind, the meaning behind what's being said. So we started to look on these intent recognition or chatbot platforms that we have. And we did create prototypes with the top players on that area. So we started with Google using Dialogflow, then we created prototypes using Louis from Microsoft, Watson from IBM, and then our current version uses AWS Lex. Not sure how many of you guys know about these chatbot platforms, but they all work pretty much very similar, although the terminology might change a little bit, but the core of the solution is the same. So they are all built around intents. An intent is basically the intention behind what is being said. I will share a little example in a few seconds, and then it will make a little bit more sense. So an intent is built basically by a collection of utterances, and each one of these utterances or sentence might have slots, and slots are variables that can change inside a sentence. So when I ask a question or I say something to our solution, this content will be processed, these slots will be identified, along with the intent behind what's being said, and then the fulfillment happens. And by fulfillment, we mean actually resolving the question that was posed. So just for the sake of example, I need to travel from San Francisco to Philadelphia next weekend. If I run this statement against a chatbot platform or intent recognition solution, we will find out that San Francisco, Philadelphia, and next weekend will be identified as slots inside this sentence. And for example, here, the intent behind it might be to book a flight, for example. And one characteristic of slots is that they might change without modifying the intent of what being said. What I mean by that is that if I say I need to travel from Houston to Philadelphia, the intent behind the sentence is still the same, although I have changed the origin of my trip. So like Franco explained, we have all that telemetry data that navigates throughout our pipeline, and we have those insights and recommendations at the end. And what we saw is that those insights and recommendations, they are specific to a domain. In our area, we can have information regarding battery, thermal, CPU. And what we did was to actually bind those domains with specific intents. So what we have built is a solution that we implement a few intents that are mapping to a specific domain, and then based on the sentence that is being asked, we can identify that domain, we can extract these slots, and with that information, we can dig into our gold information to get the data that we are looking for. So we are using our insights as a fulfillment for these intent recognition solutions. And how that fits into our existing infrastructure. So like Franco said, at the end, we have those insights and recommendations. And what we are doing now is taking that information, and instead of just making it available for reports, we are saving that for historical information. So we have all of our insights saved into a database. And what we have done is to build an intent recognition platform, meaning that we have used our domain experts to create specific intents for each one of our domains. And then based on the questions that we've, at least at first moment, we know that our users will use, then we build that solution. And if you remember, at the beginning of my talk, I started saying that we wanted to create something that was dynamic and that was available in multiple channels, not only as part of reports, right? So what we did was, okay, so we have a portal that the user can extract the reports that I mentioned that are not configurable. So we added our solutions just like a chatbot that the user can ask questions and get the responses. But that was not enough. We wanted to create, like I said, something that was available in multiple channels. So we developed a desktop application that sits on the system tray of the user that is always there for the user to contact our solution. And we also created a mobile application along with a Slack app that can be added for the teams that are using Slack, and also a call center with a toll-free number that the user might dial in and get information. All those front ends, let's call front ends, they map to the same intent recognition platform. And based on that, we can identify what is the domain of the question that is being asked, and then direct to the proper place where is the response is located. By building that infrastructure, what we were able to do was to create a solution that can first comply with that dynamic way of offering results, right? But also we created this context for the session. Every time that one of our users is contacting our platform to ask a question, the session is capped, so he can ask follow-up interactions. It means that we can have 2 or 3 dialogues open, and then he can navigate from one to other without having to restart all the discussion or all the conversation. And just to demonstrate what I'm talking about, this is an example of a fleet manager willing to know details about the battery status of his fleet. So as you can see, this user is asking for the battery status using the Slack application. What's happening there is that this will be directed to our intent recognition. We are going to fulfill all the slots that are required. Then the information will be retrieved from the database, from the specific database, because we bind with the domain, which is in this case is battery. And if you noted, the user asked for a follow-up question asking for filtering by a specific region. So that's something that previously we would be tied to development cycles to deliver. So in the matter of just adjusting the sentence or the slots that are needed, we can comply with new requests. But then while we started to develop this, we learned that well, that was not something that was specific to our team or to our group. This is a problem that happens to other teams as well inside the company. So there are other teams that are producing gold information, that are producing insights, and they lack this opportunity to share the information. So we modified our solution to create this, to offer this as a platform so people can plug in their domains. And all they need to do is create the intent, meaning that what kind of questions the users will be likely asking the system, and then provide the database or the location where the insights are stored or available. And from that point on, the platform will take care pretty much of everything and will be automatically exposed through all the channels that I previously mentioned. But one thing that you might be asking right now is, okay, it's easy to answer things that we programmed, right? Our system is just as smart as we coded, right? So keeping that in mind, we started to think about, what about questions that we don't know the answer, right? So we started to log everything that was directed to our platform in order to learn from the missed utterances. So our goal here is, for the ones that we can answer, awesome. But for the ones that we cannot answer, let's learn from it and see if we can extract value from that content. So we started to do some investigation on those specific utterances, and what we did was we did some experiments, and using, in our initial version, we used AWS Comprehend because we wanted to extract insights from these missed utterances. And what we were able to find is that all the missed utterances that we used as an input text are automatically broken into entities and key phrases. For the ones that use it, Comprehend, for example, you see that as an output of that solution. But the thing is that we are currently using is that each one of those entities are mapped to filtering slots. So these are evidences that we can use to train our own platform to be aware of those slots. And at the same time, the key phrases are pointers to the knowledge that is needed, meaning that the outcome of this processing on top of the missed utterances, we started to find out which are the domains that we need to learn. And having that information, our current implementation takes advantage of domain experts to take those questions and create the answers so we can retrofit our solution. And just to give you an example, let's say that my system knows how to answer battery, thermal, and CPU questions. And if I ask a question like, what was the health grade of my device fleet yesterday? This is something that the system doesn't know. So what happens is that this will be flagged as a missed utterance and will be fed to our algorithm that will bring as response that health grade and device fleet are knowledge that are needed for that particular user. And at the same time, yesterday is a date or a slot that needs to be filtered. That means that we can take this information and we can look into our code to see if we have answer to that. And by having that, we can create new intents and adapt our solution. And what is the difference here between the knowledge and the date? Well, basically, the date is something that can change, meaning that the user can ask, what was the health grade of my device fleet 2 weeks ago, for example. The intent will still be the same, the knowledge needed still be the same, but it's a different time frame. So that's something that we take into consideration. All right, so another thing that you might be asking yourself right now is, okay, you said you had static reports, and now you have reports generated through the natural language, right? But they are still reports, right? Because at the end of the day, it doesn't matter if it's a report on paper or a bot replying with the information. If nobody does anything with that information, it will be lost, right? For example, if we get the insight that Franco's device has a disk problem, if nobody takes action on it, he probably lost all of his information. And at the same time, we know that all of our devices are connected. And we do have the information. Why not deliver that to the actual devices, right? And this is something that we are currently working on. So we are creating a solution that as soon as we have the insight, we can deliver it, or we can plan the deliver to a better time. Our idea is to help the user and the fleet manager to solve their problems by fixing in advance or helping the user to actually fix their devices. And how we are doing this? So we are still using that initial pipeline. We are still processing the telemetry data, and we are still feeding our databases with the knowledge that we are exposing through our natural language tool that I just shown. But we are now also using a simple query that our analytical services are, fulfilling with insights and recommendations that need to be delivered. And what happens here is that as soon as we have an insight that is filled to our event sync, we are wrapping that in form of an event. And an event for us is a collection of actions. So in the example that I mentioned with Franco, for example, we could have that insight delivered in form of a notification to the user, and the actions to be taken could be, first, open a ticket with IT asking for the disk to be replaced. We could send an email to Franco's manager, let him know that there's a problem with one of his employees' device. And also, we could automatically start to back up Franco's files, for example, and ask Franco's for advice on what extra files are needed to be, stored on this backup. And at the same time that we are doing this, we could also use this same solution to retrofit our initial pipeline. For example, if we have an insight indicating that a particular notebook, for example, is having a problem, we could deliver a notification in form of an event to the user indicating that, well, something is not right with this asset. Let me go ahead and start an intensive telemetry. That will trigger an action that will fire up our algorithms, and more telemetry data will be fed to that initial pipeline. So we'll have a more specific granularity of information to be processed. And just to demonstrate an example of this, this is not actually a real use case, and probably the actions that are taken here are not actual recommendations that one will take, but this is just to give you an idea of what's happening here. So this is a simulation of a user that is facing a problem with his computer. Basically, what I have done here is I create an application that is consuming 100% of my CPU and doing multiple I/O operations. So my system is unusable. So let's say that this particular user here is not quite familiar with technology, so the user doesn't know what exactly should be done here. So he picks up the telephone and tries to call the call center asking for help. I'll stop talking so you can listen.
Hello, how can I help you?
What's going on with my device?
I have identified an application that is consuming all of your processing power. Can I finish the execution?
Yes, please.
All right, I think I have finished. Let me know if you need anything else.
So what happened here was that I asked a simple question to this call center. I could ask anything along those lines, like, I can't work, my computer is stuck, I don't know what to do, I need to do my work and it's not working. Anything like that will fire a specific intent, and that will be delivered in form of a notification that is composed by multiple actions. One of the actions is try to find for any potential application that is offending the overall execution. And if the user agrees, then let's end this application execution. That's why when I answer yes, you probably noticed that the application was finished and my CPU power was released. And before giving back to Franco, I just want to finalize by saying that all the work that we are doing right now is pretty much about the end user, or to amaze our audience, right? We are talking about helping the fleet manager at the same time that we are trying to amaze the end user. We are trying to act in advance to help the user to understand the problems that they are facing and probably helping them to solve them.
Yeah, and as I began speaking about learnings, and every time we did something new, we noticed we have a way to walk. So when we built this thing, and when we noticed, okay, we want to have immediate delivery, we rapidly noticed, okay, nowadays when we have the typical telemetry device health data services, what the devices send is then send the data not very often to our cloud system, because a disk status doesn't change very often. So sending data once a day, twice a day is okay. But as we imagine here, for example, CPU thermals or processing, we need to identify the event and then start triggering, okay, send me data, and then having a streaming to capture this data and process to deliver the data back to the action as Zotto just showed you. And then we notice, okay, if you want to really, really fulfill this thing, we don't need to rely on cloud. We need to do this on the edge. So this is the next step we are doing. So we are using Databricks Spark to get this data, this massive amount of data from different devices, train our models, but then we update on the edge these models to run these inferences on the edge as he showed here. Okay, there is something wrong, I immediately deliver an action. So this is something that we are working on today. We did the same presentation for our colleagues in HP a couple weeks ago, and then the adoption was, the discussion there was like, okay, so do you have an intent repository? Because if we are delivering this for everyone, and it's easy to create a new intents in new domains, as Zotto just mentioned, so do we have a way to create an intent repository, and then let's the robot, let's the chatbot discovers what services we have available. So this is another thing that we are working on now. And the third thing is like, some users are using, some groups they use, as Zotto mentioned about terminology, some use a different notation to describe the intents. For example, Google's like, another one uses Microsoft's like, another one uses AWS like. And then what they request, and we didn't have an answer so far, is like, can you have agnostic intent descriptor? So this is an open question. We don't have an answer for this solution today. But the first two ones, running on the edge and having a automatic discovery of new intents, this is ongoing. And this is pretty much what we have for today, and I hope you liked. Thank you.
Thank you.
We have time for questions, so you can come up to the podium. We have mics on both sides.
Hello.
Hey.
So in your demo, you asked about your computer was going slow because you had a process. The bot asked you if it wanted to kill it or shut it down. Does it have like contextual memory? Like if you had asked it to describe what it was, did it know what it was already telling you before so that it could like give you more information about what was going on there?
So yes, we could have done that. Like I said, this was a simple demo that we created just to demonstrate, but we could have done that, but also we could, the idea is to not only ask for follow-up questions to get the user perception of what's going on, and this is what I mean by understand the user profiles. We are also interested to know how the user is feeling the device, but that along with what we are actually seeing on the device. So our interest is to have both information so we can, compare information. So I'm seeing that your computer is in a particular state of execution, and you are saying the same thing. So that will make sense. Okay. Or the perception that you have is quite different than what the system is telling me. So that's something that we are interested. Okay. And technically, we can do both. And I would say that from a solutions perspective, that is exactly what we want.
So can that profile also be based on call history? Like the user profile that you're creating, basically, like if they ask certain types of questions, you would have that kind of information about the person?
So good question. Everything that we ask our system is recorded, is stated for as a background information. So we have all the conversations per se. We have everything that is said to our call center is also stored. And we also save all the responses that we gave. And like I mentioned, everything that we cannot comply, I don't know the answer, so we keep track of that as well. And we do that bind to a specific user. So one of the things that we are starting to see if we can implement is to actually, for example, let's say that you asked a question, I don't have the answer, and immediately what I'm going to tell is, unfortunately, I don't know the answer, but let me look it for you. That's what we are trying to do. Mm-hmm. And once we have our domain experts and we have the information available on the system, then we can track back to who originally asked that question and say, hey, now I have your question. Is it still something that you want to know?
Cool, thank you.
Thank you.
Hi, this is very impressive.
Thank you for a great presentation.
Thank you.
But I would like to say that you know about the privacy problems with this kind of things. I mean, because you're sending all the information to the cloud, and maybe you're picking up information that, when people are cursing at your printer, you don't want to pick that up and send to the cloud. So the question is, and actually I love your work, I'd love you to succeed, but all I'll say is, have you given any thoughts to how you protect privacy? And there are many ways to do it, but you'll have to intentionally do it. Otherwise, all your good work will be attacked at some point.
Yeah, in terms of privacy, that's the reason we are focusing on enterprise segment first, because it's easier to get the approval of the companies and the users on that specific domain, specific context. And although we see that it's very valuable to consumers' space, this is something that we are thinking in how to do that. One of the possible solutions we are imagining, instead of saving everything to the cloud, is running on the edge. And instead of training in a centralized way, doing a federated learning to share not the data itself coming from the different individuals, but sharing the weights coming from each one of these things, and then training the models in a centralized way and redistribute. So for privacy, we are thinking focusing on enterprise with the current solution. In the future, probably federated learning.
All right. Well, whatever you do, keep it in the open so no one has any reason to doubt or.
Sorry?
No one has any reasons to second guess or doubt what you're doing. So if you keep everything in the open, that would help the users.
Yeah,
I use your HP printers at home, but I don't like
Sure
my
thing.
HP user printer to be listening to me.
Yeah.
Hi. So this is more a follow-up on the point you mentioned about the intent library that you guys are building. So I guess as your space of intents increases, there will be conflicts, right? And your utterances will clash with each other. So I was wondering if you also have some kind of an entity library, and do you curate these entities, or how do you do you use entities in your NLP? And
Yes.
if you do, and how do you get the list of entities? Do you,
Awesome.
Yeah.
Great question. So right now, what we are in the early steps of this solution. So basically, what we are doing is every intent that we build, we put it into our bot. We have a centralized bot, and like I said, we are using AWS Lex. And once you add a new bot, a new entity, a new intent to the bot, what happens during this build process is that the utterances used for each particular intent are not conflicting. So that's, I guess, is the question.
Yes.
Right now, what we are doing is basically we control that manually. But I think Franco mentioned that our idea is to create something that was even easier to use. I believe that AWS interface is quite easy to use, but we want to create an additional layer in front of it so other teams can build their intents, and we could use some sort of meta language to describe, and then we could resolve those conflicts before sending to the bot. So the idea is that when you are creating a new intent and you have some conflicts, we can identify that probably will have some conflicts. We can follow back with the user and say, hey, wouldn't that make more sense if you add to that other particular intent? But this is something that we still don't have. So.
Nowadays, you're resolving the intents through a Lambda function, then based on the...
Yeah, so one thing that we did, while we were building specific intents, we learned that most of the questions are quite similar, right? The only change was the service or the domain that was asked. So one user might ask, what is the battery grade? And the other one might ask, what is the thermal grade? Right. So the sentence is pretty much the same. Right. So we figured out a way to resolve by creating a specific intent and then just modifying the slots. Like I gave the example of changing the origin of my trip. I'm just changing the domain of the question.
Based on the slot.
Yeah, and then we avoid an explosion of intents.
Yeah,
Exactly.
so right now our solution, we take care of how many services we have?
About 10?
Yeah, around 10 services, and we have just one intent and one Lambda function, so it's very concise.
That's awesome. Thank you.
Yeah, thank you.
This is going to be the last question to my right.
You've mentioned how you analyze the different services, Dialogflow, Lex. What led to that selection of Lex? What did you find was better about the service? And also, have you thought about localization, internationalization?
I didn't get the second part.
Localization, like multiple languages.
Yes.
And all of that.
Okay. So for the first time, why we choose AWS Lex? I think the easy answer for that question is pretty much all of our stack is implemented inside AWS Lex. So that was one reason. And the other one was that I think since all of our services from this very same stack are located inside AWS, the connection will be easier, right? So we didn't have to have multiple clouds. So one solution, our first version was using Dialogflow. We had some issues to create the initial version of it because we are not very familiar on how Dialogflow worked. But then once we got it working, we came to a problem that we are using two clouds, right? And that was something that we try to avoid. We have this particular rule that we try to keep solutions inside a particular provider. And our choice inside our group is to use AWS. So that's probably the reason.
In languages? Multi-languages?
Oh, and multi-language. So yeah, we are not, right now we are not very concerned about that because most of the usage that we do have, we are, right now we are eating our own dog food, right? And pretty much all the clients and users that we have are in English. So we are focused on that, but we do have that in mind. And probably the solution will be using yet another AWS solution for that, or service for that.
Or our own.
Yeah.
Thank you so much, everybody, for coming.